Linked lists. Okay, so linked list is a type of data structure, and it's a little bit more flexible than an array. So let's go back to our model of an array. Okay, so this is we're not talking about linked lists yet. We're just talking about arrays. So let me just for comparison over here write what happens with an array. Okay, so with an array, we've got our little memory model here. And actually, I learned a little trick with my drawing program here to make straight lines. So let me try that again here. There we go, that makes a little bit straighter line. And I'll just draw these. That's fine. So as long as we have a sort of straight outer box. Okay, so with an array, what happened when we say we declared my array, and we'd say, okay, we're going to use 1, 2, 3, 4, 5, and then this would actually be my array of size 5. With a linked list, we can actually do something. We talked about our static arrays, and one of the things that we had to do so this is a normal array, and then when we had our vectors, our dynamic arrays, when this filled up, we would we would grab other areas of memory, find us 10 addresses of memory in a row that were available, and then we go ahead and copy that over. And that copy operation, there's some debate on whether that's wasteful, right? Because every time we reach a certain size, we have to actually stop the program, copy a bunch of stuff over, allocate new memory, and then delete the old stuff. And so that takes up some time, especially if we're so used to computers running extremely fast, billions of cycles per second, but in computer time that can actually be a lot, because what if we're not talking about 5? What if we're talking about 100,000 or a million? If we're talking about copying 700 or 800 megabytes of memory from one region to another, that can get and that's not super atypical of say a program like a video editing program that has these giant files in memory, or if you're working with what's known as big data, if you're Google, and so that may sound kind of crazy to copy around 700 or 800 megabytes of memory at a time, but that's kind of realistic for some applications. So and this linked list goes back a while, and maybe I'll post the Wikipedia page to it, because it's actually a very useful data structure, but it's pretty old as far as computer science goes. So let's make another memory model here. And this is, get used to drawing these, because this is kind of just the way you see memory written and drawn out. And then a lot of times you'll see right next to it, you'll see they'll actually write some addresses. We don't have to really worry about it. Let's just assume that these are some addresses. And what you do with a linked list is, instead of pre-declaring how much memory you need at any given time, and so what I'll do is I'll kind of black out some of these boxes. So the ones with scribbles are unavailable. Somebody else is using them. Okay, so that's good enough. So I have the first thing I want to insert into my list, and so what I do is I come along and I say, okay, this is available. So I take this one, and then so right now my array, or I should say my list, is of size 1. And so if I had an array, I would have had to pre-declare all these, but because I've only used one so far, this is the only one I use. And so what happens is, as you use new ones, you point to the next area in memory where the next one's going to be. So, and this all kind of happens magically in the background. So the next available one is here. So when I want to use the next area of memory, and so you can kind of see why this would never fill up, because we just always, and there's no reason it couldn't be the next ones and the next ones. So you can see what's happening here is every time you add something, because they don't have to be all in a block in a row, just like our array. So our array, they all have to be one after the other. Um, it grabs the next available piece of memory. So there's advantages and disadvantages of this. Right now, initially, I'm not going to make you code it, and eventually we will code it, but you're going to be able to pretty much copy and paste. You'll just need to understand sort of what's happening in the background. But essentially, arrays are good for situations where you really want them to be one after the other. And there's reasons in computer architecture. There's something called prefetching, and this is again for anybody who's a computer science major. What happens is when your computer comes along and it says you're going to use this one, well, so say I wanted to use my array 0. Well, the computer, if you've ever seen on your CPUs, they'll talk about L1 cache and L2 cache. This puts it directly on the CPU, but at the same time, it takes this whole thing and says, okay, statistically, and this is what they talk about locality. And if you ever take an operating systems class at say a university, you'll talk about this. But it actually grabs not just this one, but it also puts these away temporarily, because it says statistically you're probably going to use these other ones pretty soon. So you're only going to use this one right now, but you know what? In the background, just kind of magically, I'm going to grab all these. And so when you go to use myArray1, well, it's already available. So that's an advantage to using an array. But as I said, if you're using these giant arrays, well, the L1 cache and L2 cache is only so large. So if you've got an array of a gig, and then it fills up and you need to do a copy, well, you're not cached anyway because the cache isn't that big, and now you've got to do this giant memory copy. So those are sort of the advantages and disadvantages of an array, is that when you actually do the copy, if it's a small amount of data, it's not that big of a deal. Large memory copies can take a while, and they can be pretty severe. But if your array is small, you get the advantage of keeping these all together and actually prefetching and caching. A linked list, every time you make one of these little pointers, well, the computer has to go through and actually search and say, okay, this one's not available, this one's not available, this is the next one that's available. So there's sort of a fixed amount of penalty that you get for each one of these, because you haven't already pre-allocated. Every single time you go to insert into a list, this process has to happen. Also, there's a slight overhead, and we'll see when we actually code these, that we're not just using an integer anymore. So in here, we're just using an integer. We're using an integer plus a little bit of extra memory, a little bit of extra area for this pointer. And so it's a little bit less efficient. So there's advantages and disadvantages. But right now, I'm going to let you take the easy way, and we're just going to use STL, and we're going to do just like we had vector. We're going to do an include of a list, and there's different types of linked lists. There's a regular linked list, and then there's a doubly linked list. And so instead of just pointing this direction, we also point backwards. Some of the other advantages between arrays and linked lists: if I want to go to a specific element in an array, say I wanted to go all the way directly to 4, so we wouldn't have to go 0, 1, 2, 3, 4. The computer knows exactly where this one is. So if I want this one, the computer can basically just instantly just go right here and grab it. It doesn't have to do any sort of calculations. Well, if I want this element right here inside the linked list, I have to start here and then go through and say, okay, now I've hit this one. So there's some penalty with that. So as I mentioned, there's some advantages and disadvantages, and we'll keep on bringing those up as much as possible. The actual coding of the data structures isn't that terribly important. It's really understanding what's going on underneath and the advantages and the disadvantages of these different types of data structures.